Hey guys, and thank you very much for joining us tonight. Tonight we have Eric Askue with us. He's one of our amazing instructors over at XMD Academy. Tonight our topic is rapid model preparation for 3D printing. We'll be covering the top 5 most important rules when sculpting 3D prints. Why an increased poly count will not increase the quality of your print, and how to avoid pockets and envelopes and what to do if you encounter them, and a lot more. Without further ado, let me introduce Eric Askue.
Hi. My name's Eric Askue, and I am a 3D artist, and I focus on making models for 3D printing. I work with 2 companies primarily. I work with Haldane Creations out of Virginia and Collapse Industries out of Pensacola, and we print in the United States for various people and products. If any of you guys read the article on 80 level, you would have seen the baby dragon that was done out of Pensacola for Rick Cantu. And my job is to either make the model or I make other people's models print ready. We usually refer to that as engineering. But basically what we're going to go over is like I said, like Mike said, we're going to go over some quick tips and some things that are really important that people really aren't paying attention to or don't know about. And that's like the main focus of the whole course, is how to take a model and really make it print ready in the smart way, because there's a lot of work that goes into it, and a lot of artists just make the models, they don't make them print ready. So somebody like me has to come along and make them print ready. So we're going to talk a little bit about that. I think I saw somebody's in Montreal. That's pretty cool. Jersey, Providence, Maryland, Germany, nice. Germany, Taiwan. Oh wow, Taiwan. Holy cow. Idaho, Sacramento, Florida. I miss Florida. Monterey. Okay, New York. Somebody's in my backyard. So just so you guys know, I'm actually based in Connecticut. And this, although my basement doesn't look like much, this is a proper studio. It's a working studio. I've got molding, casting, and 3D printing equipment here. We do a little bit of testing for the 2 companies that I mostly focus on. So I'm going to start sharing my screen. I'm going to show a model from Spicer. I'm going to show you guys a demo that I put together just for tonight to just sort of elaborate on some things. But I really hope that you guys ask a lot of questions. It'll give me an opportunity to show you guys things or talk about things with the limited time that we have. I'm not going to get into certain areas of 3D printing. Like, for instance, we now 3D print our mold jackets out of, I think it's out of vinyl. It's either vinyl, no, nylon. We 3D print our mold jackets out of nylon. We're not going to talk about that stuff. That's actually in the course. But let me turn on my share screen. Actually, no, before I do that, real quick. So right next to me, I have models that are 3D printed in FDM, okay? And this guy here, this is actually printed completely supportless. Actually, both models are printed completely supportless. So FDM is the extrusion style printing. This one shouldn't print supportless, but it's got a seam running through the middle, so it opens up and lays on the bed. But this guy's got undercuts. So undercuts is a common term that we talk about with 3D printing. But then SLA is these guys. So this guy and the baby dragon and this guy here are SLA prints. And these are different styles of SLA. One of these was done DLP, or digital light projection, and the other one was laser, which we're starting to move away from. So a lot more people are using DLP, SLA, or I want to say OLED, but that's not right. So there's a lot of different things that are coming out. In fact, one of the most interesting things, just real quickly, is that for the second time, A company has announced that they have continuous printing. The first one was carbon, and another one just announced this. A university or announced that they've got a model for continuous printing, and they're looking at SLA printing that can print almost 24 inches in an hour. So 3D printing is going to be changing a lot in the next couple of years. So I hope you guys are really excited about that. So let's get into some actual models and some of the work that I do. And I'm going to change over to share screen. And I might jump around a little bit, but let's just start with this guy. So this is Spicer McLeroy's Batman that he's working on, or they'd finished, and he sent it over to me to make it print ready. First things first, I have to close up this piece of material in here. I have to close up some of these gaps and make this more fused together. So I'm going to end up using blocks in there. But one of the things that usually comes up when I look at somebody's model is certain types of defects. So this is a defect here. This is very similar to a floater. And you'll also see that there's some holes here. I already took some of the debris off. But this is something that really can make a mess out of your model, because this will not stay attached and it will become a floater in your model. So I'm just going to quickly go ahead and remove this. I'll show you how we do that. So I'm going to do selection lasso, and I'm going to use that. And in this case, we're just going to remove it. And a lot of artists, even my models, sometimes get stuff like this. And when I'm engineering somebody else's artist, you're trying to maintain the essence of the model, but you're also trying to remove debris and things that are going to screw up the print. Like this little prong here, if that was big enough, that could really make a mess out of things, but I can probably just get rid of that. So from here, I just go ahead and I delete the hidden portions. And in this case, I'm just going to run close holes. And we can collapse them, but again, I'm looking to maintain the relative essence of the original artist. I don't want to have to go and clean up his work or change his work in any way. But that's one of the first things I wanted to show you guys. The other thing I want to show you guys is that this model's covered in texture. Most of this model has texture on here for one reason or other. And for instance, this cape, which has already been decimated. This has been decimated to the point where it's starting to take on a crystalline appearance. That's perfectly fine, because even though this model may be, let's say, 14 inches off the base, most of that stuff will print through in a way that will be representative. Some things, though, like the body, this may not come through and it may come through. And one of the reasons that we want to try and put some amount of texture on things is because a clean surface is going to show Z layer lines or grow lines a lot more. But I have to go through here, and what I usually do with Spicer's work is he builds in a particular way, and we end up having holes. So I end up decimating, and then I run close holes on the given parts. And I might actually slice this before I run close holes, because it is very dense. In fact, all of the parts on here are pretty heavy. Some of them are pretty extreme as well. But you want to go through, you want to close all your holes. I'm working on the cowl. The cowl is actually a bit of a bear, because it's got some defects that came with the model. But I've already closed off the inside and decimated that a little bit. So this guy's ready to go, and that'll print nicely once I fix the nose here. Most of the time, models will have this kind of thing going on, depending on what type of effects the artist is using. One of the things that you want to try and do as often as possible is make sure you have your parts well and thoroughly embedded. A lot of the time, the thing that causes pockets and envelopes is when a piece of armor or multiple pieces of armor are not fully embedded, or they're not embedded deep enough, and you end up having to clean that up as an object. So we're constantly talking about how far do you want to push it. Same thing with similar thing with the cape. The cape goes into the body quite a bit, and this is again to make it a little bit easier to print because it's got some thickness, but also to make sure that it completely encases the structure. Now, I don't have an envelope, but usually a pocket or an envelope will happen between areas of material. So for instance, you can see the cape and cowl. There might be an envelope or a pocket underneath here. And until we do a CAT scan, which we may not be able to do, or we may try to do that, we might get one. So this one here, I can actually see this one. This one's a pocket. And I think what we'll do is we will turn off the base and turn off the arch. And I'll show you guys, I'll do a quick CAT scan for you guys, give you an idea about how I identify that stuff. So any questions about what I'm doing so far? Because there's a lot of cool concepts here that I just don't want to talk without. I don't want to miss a question because I talk too much.
Ivana asks, do you have a specific workflow or steps you follow when it comes to looking for these kind of issues to make the model 3D print ready?
That's kind of what I'm going to do right now. And although I'm going to go into this in depth in the course, I'm going to give you guys just a quick overview. Most of the time, it's just about understanding how a model works. I know that doesn't really tell you anything, but the truth is that it's partly experience and it's partly a lot of practice. Since I do work with 2 studios and two very professional individuals, what I find is that the more experimentation that you can do when things fail, the faster you're going to learn. So because I haven't closed up all the model parts, the inside of the cowl is showing us a pocket. This is a pocket. But if I come down a little bit further, you can see that the cowl right here is showing a little tiny space. And again, that's going to be like an envelope. If this model was fully closed, because I'm still working on this, I just got this model last week. If this was fully enclosed, I'd be able to fill that in with a piece of geometry and get it ready for print. Most of the time, envelopes and pockets look like these little openings here between the cowl and the armpits, or the cape and the armpits, and the back of the model. And you just have to figure out what you need to fill in and what you're going to leave behind.
So what kind of issues does the pocket actually cause with 3D printing?
It can lead to vapor lock, which causes your model, if you're doing SLA, it causes your model to, vapor lock causes a bubble, which causes your model to float, which breaks it away from the build plate, or the more horrible thing is it can cause a cascade failure. A cascade failure looks like a triangle that opens up in your model and continues to open up, creating a giant wound in the surface of your model. That can happen for many reasons, but the envelopes and pockets is the most common reason that happens, and it just means that the model wasn't thoroughly checked before printing.
MB753 says, what is the best way to have watertight meshes? Dynamesh or remesh by union?
Neither. I don't use those methods for making my mesh watertight. Simply put, the process I use is we Boolean given parts together, and then I go ahead and I fill in any holes and gaps. Booleans works a little bit better because Booleans do not work on open surfaces. You cannot use a Boolean on a surface like the archway that I started with that have holes in them. Most of the time, I use a various number of techniques to get the desired result. But the problem is that once a model is sculpted, running Dynamesh or remesh on it, or anything else like that, will ultimately change the artist's work. And if I'm working on a client's work, that is inherently bad. You'd be surprised. A lot of the times when I get an artist's work, they're very flexible. I got to actually make minor edits to the Thor piece for Spicer so that we could get that model out. And there was a lot of flexibility there, but some artists are really, what I give you is what I want back, and that can make your job infinitely more difficult. Thankfully, I don't run into those people too often, but I have had dealings with companies that require you to not make edits, even if those edits are going to save yourself and them a lot of time and aggravation. That's just the way that it is, though, because you're working for a client. So let's see here. I think you might have meant, you know what, MB753, you might have meant Boolean by union. Instead of remesh, because I don't, ZRemesh doesn't have a union function. So maybe.
I think they meant Boolean.
Yeah, I think they meant Boolean. So yes, I use a Boolean function to finalize pieces. It works really, really well. But filling in holes requires, usually what I do for filling in holes is I will switch over to the part. So if I grab the cowl and I just grab a sphere and I'll dump the sphere in and then move it around, and just like making your bed, I tuck it all in with a snake hook or something like the snake hook, or even clay. And I'm not really going to do this right now, but give you a rough idea. So I'll just sort of, why is this not working? Oh, there we go. Yeah. I'll just tuck this into the model, just like so. You know, push it around, fill in the gaps, and once I'm happy with it, then I can Boolean it and fill in that hole. And that almost always leads to floaters, and floaters are little pieces of debris, and those have to be removed also. So those are the big things that really cause a lot of trouble for most models in printing. Envelopes, pockets, floaters, those are like the big things, and those things can lead to either defects or catastrophic failure in a print. So you got to be really on top of that.
Can you explain what an envelope is?
Well, an envelope is basically when you have, say for instance, this cape. If this cape had a little tiny opening, but then it had a cavity behind it, and that's what I usually refer to as an envelope. So. Let's see here. Completely brain dead. So I wanted to show you guys something cool. I made a little demonstration here to show you guys the hardest thing in the world to print is a dome. Domes, clean surface domes are the hardest thing to print, mostly because they show the Z layer lines the most, and that just means you have to spend a lot of time cleaning up. So I made this little demo to show you guys what a little bit of noise can do. So you can see as you move up the dome, the layer lines are going to become more and more apparent. And if you add a little bit of noise or texture, the Z layer lines are irregular, and this can help to disguise the layer lines in a model. Thankfully, we're getting to a point where we can print them finer and finer and finer, but knowing this kind of thing is part of really good production. It's orienting your part so you either hide the layer lines or reduce cleanup or just make the model easier to print. And it's kind of like one of those graphs, you know, you can have it good, you can have it cheap, or you can have it on time or quickly. And it's the same thing with 3D printing. We spent a lot of time trying to figure out the orientation of our models to reduce showing things like that. Luckily, most of the stuff we do is organic, so domes don't show up very often, but they almost always show up on things like the shoulders. Sometimes they show up on cheeks. Luckily, we can put textures on those things to help reduce them. I don't have my notes in front of me. What else were we going to talk about?
So you're going over.
You guys have to forgive me. I have two monitors, but I can only have so much on my other monitor.
The FDM versus SLA. Now you wanted to talk about why you would hollow an SLA but not an FDM.
Oh, right. Yes. So a lot of people think that you, for a while there, a lot of people were saying, hey, we need to hollow out our parts so we can save money. That's not the reason you hollow things. If you hollow an SLA, you're trying to reduce how much of the model is going to stick to your membrane on an SLA print, and it's easier to pull off when you have less surface area. It also, with laser, for instance, you would also speed up your print. Now that we moved mostly to DLP, it really doesn't matter. But reducing how much surface is sticking to that adds longevity to the membrane, and it also allows the part to come off. With FDM, hollowing a part actually means that you have two interior walls, which can cost you a lot more material in the end. Most of the time we 3D print FDM as low as 10% infill. We very rarely print it with what we call complete infill, which is about 92%. You can't go any higher than that, or it starts to expand and you don't have any, because it's an extrusion style. But yeah, that's the main reason to hollow out parts. You got to make sure you have a vent and a drain so you don't create vapor lock. You don't want your part coming off. But yeah, that's a big deal. Most of the time, I will do that in my slicer. We use a couple of different slicers. I'm not going to name them all here, but they allow us to really go for the best results depending on the printer we're using or the method of supports. Most of the slicers slice pretty standard. They put out a pretty standard. I'm trying to remember the name of something that I can't remember the name of, so I'm going to move on. Yeah, they put out a pretty standard file. What was the other thing on there, Mike?
You got orientation. Why is it so crucial for printing?
Okay, so let me just show you this. So if you look at, say, for instance, these gloves. If I print this glove on its back like this in an SLA printer, I've then got all the supports that are going to come off the back of this, and the print might print faster, but then I have to spend a lot of time in post-processing. If I can orient this, and I'm going to isolate this just a little bit. There we go. That'll make life easier. If I were to orient this, I would spend some time looking at where the Z layer lines are going to show up, and I would try and get it into a position similar to this. Maybe not exactly this position, but I want to balance it so that I have the fewest number of supports, and the further up I go, the fewer supports I need. And that's going to reduce the number of supports, but I may get Z layer lines showing up dramatically across the knuckles. Luckily, there's a surface texture here, and that's going to help to disguise that. But if I do start seeing those Z layer lines, I can reduce it by either putting some camber on it or putting an angle on it and tilting it in another direction as well. So you can put multiple angles, 2 angles, 2 out of 3, on the position of your model when you're getting ready to slice it to print. But orientation really does matter. And I've had a few models recently come across my desk where the individual oriented the part in such a way that the lines showed up, almost like this would be probably one of the worst positions to 3D print this. You need a lot of supports, and because the back of the wrist is going to be the hero angle, basically what people are going to see the most of, this area here is very long and very shallow, and it has this ever so slightly domed appearance, just like a sphere. This would create the most visible layer lines, and it would ultimately make that part of your print need much more post-processing, probably to the point where you'd end up sanding off the stitching.
Do you have a good technique to show, like kind of preview what you would get as far as layer lines, depending on what orientation you have?
I don't have anything that I can show except to take this part over to my other demo and give you an idea. So we'll do that. So let me clone this, and then we'll bring that in here. And I didn't need to clone it. I could have just appended it, but didn't think about that. Let's see, delete hidden. Or delete hidden here. There we go. Move that to the center of the world. Boop. Oh, they're tiny. So, there we go. So we'll put this up here, turn these guys off. So I'm going to show you the worst possible orientation for this part. We'll leave the grid more or less alone, because there's you do get a display grid in most slicers, and you can run through that display grid. This is a pretty ugly example, but it gives you a really good idea about what's going on. And you can see how thick these bands are, especially across here. And they're they're really, really thick. But they're much thinner as you go around the bend of the arm here. So again, if I were going to orient this for printing, I'd probably put it up like that. And the layer lines are going to be much tighter. And you can see it when I turn this guy like that. You're still going to need a certain amount of post-processing, but ultimately, this is an experience thing. You'll have to spend a lot of time playing with your orientation depending on the part. And sometimes you just got to bite the bullet and say, this is the way that it's going to print. You can't get it 100% all the time. So we will see. Again, thankfully, with the continuous printing that's supposed to be coming out, layer lines are going to start to become either significantly less apparent, or they may end up going away altogether with those types of printers. But we don't have those yet, and even if something was to go on the market, say sometime next year, we're still going to have to deal with them for now.
MB753 asks, what kind of resin printer do you use in your company?
We have several different types of printers. We have roughly, between the two companies, we have about 40 printers. So we do have a Form 2, but we really don't use it much anymore. We also had a Milkshake, and those, I don't want to say they're being retired, but they require a lot of maintenance. We actually really like the Frozen. We have the Frozen. We're really happy with that one. In fact, we'd like to get a couple more of those. I think we have a couple more odds and ends, and there's a few inexpensive ones out there. In fact, Jillian told me about one that we've talked about a couple of times, which is really inexpensive. I just don't know the name of it off the top of my head. Most of that stuff I have to look up, and sadly, I have limited space to look at things while I'm doing the demo today. I wish I could give you guys more information on that. Did I see something about a Boolean method? Do we want to do that? Do we have time for that?
Lee's asking if you could do a demo for Boolean Method.
Boolean method is pretty straightforward. Basically, you take a part, and for me, the tool that we made available previously was my SLA tool, which is the key tool. I hope this is the new version. I'm constantly making edits to this tool. Boop, there it is. Yep, this may not be the latest and greatest one, but so what this tool is that this is a male and female key tool and a cut plane. And I use it as a brush because it's easier for me to do it that way, and because unlike my other key tool, this one can be any size and any not any size and any shape. This one can be vary in size depending on what I'm doing. So essentially, I just place this guy, get this guy situated. And in this example, we're going to orient this just like we would do a mold and cast. So split head. And then I set this, I'm going to leave that alone, and I'm going to turn that on. All right, so what I'm doing is I'm just trying to get it situated so I can see it. I just want to be able to see the key, make sure it's embedded, make sure it's not too ridiculous. So I'm looking for how it orients to the part. Generally speaking, that's not the button I wanted. Pushing all the wrong buttons. There we go. So I just want to get this guy oriented a little bit nicer, a little bit smarter. You actually do end up cutting off hands at the wrist when they have weapons, so this actually works fine for this demonstration. Generally speaking, when a character is holding a weapon, you want the weapon to stay attached to the hand. So you usually key either the hand or the wrist, or you could key the forearm or the wrist. In this case, we'll just do the forearm. And so what I'm going to do is I'm going to go ahead and auto group just to make sure I didn't mess that up, and then I'm going to do group split. And if the part came out properly, yes. So that's my male and that's my female. I got to pull that up. I'll set the male and female, or the female and the cut plane to negative, and I'll set the male to positive. I'm going to grab the plane, or I'm already grabbed the plane. I'm going to go to the edge loop. I'm going to set this to 0.0025. Zero out the other commands. I'm going to run the plane and see how it looks. It's a little too thin. So undo that and 0.025. Still a little thin for the part, so we're going to make it 0.25. That's better. So you always want to take out a small amount of material. A lot of people think that tighter is better. Well, guess what? It's not. And the reason for that is that if you overbake, or if you have light bleed, or if you have swelling of your parts, they're not going to key together very well. And a little bit of tolerance is really good for you. So we're going to go ahead and run Boolean, which doesn't work if these buttons are on. So we're going to run Boolean. Oop. And ZBrush decided to crash. Yay.
It's not a successful demo if it doesn't crash. Lee was asking, you stated you would Boolean the entire model. Just curious more of how this is how you would merge or fit the subtools to each other.
It's very similar to this, but it depends on the part. See, when I'm going through parts, there's an orientation or a collating system, for lack of a better term, that I use. So I kind of keep like groups together, and I will decimate them, Boolean them down into their like groups, and then I will proceed with the cut-up process. Sometimes that works to my advantage, and sometimes on really complicated models that can make life difficult. I have a couple of tricks, but it really depends entirely on the part, and it really depends entirely on the given method. I know that doesn't make a lot of sense, but it's something that I would have to spend some time actually showing you with a more complex model. And I can't go. We've only got about less than half an hour already. So, and I would love to talk to you guys about it, but time is limited. Whoa. What the heck? I don't want this. Let's try that again. Oh, now it draws the way I want it to. So I'm going to do this quick and dirty. I'm not going to spend any time on it. I'm just going to run it. So just bear with me, just so you guys get a better idea about what's going on. So I needed this guy at the top. I need this in a folder. There we go. Grab that guy, split hidden. Got that extra arm, we're gonna get rid of that. Delete hidden, auto group, group split. There we go. Grab panel. I'm just gonna give this any old thickness. So normally when I do this, I spend a lot of time checking the thickness because, like I said, tolerance matters. That's why. Wow, that was crazy. Let's try this. That's way too thick, but for point of example, it's fine for what we're doing right now. That has to be, it's best if that's underneath the female key, and the male key should be at the bottom. And these guys are going to be negative, and turn that on, and then run Boolean, and hopefully this runs properly. Boop. There we go. That's what I wanted. Hit auto groups, and I have a female key and a male key. And it looks like I got some floaters at the same time. One of the things that's most important about this, just so you guys know, is that the male key should have draft angles on it or bevels, and only these planes, this plane here, the four sides, only those sides should come close to touching the inside of the female key. The top and the sides here shouldn't touch anything at all. And you want these to be beveled because it improves the longevity of your mold. Harsh angles eat your molds and casts if somebody's going to make duplicates, but that doesn't really matter so much with the female. For the female key, it really doesn't matter at all. However, this is a huge no-no. You want to stay away from the edge. Also, you'll notice that my key is rather stout. Keys are not structural in making your model come together. A lot of people that make overly long keys end up weakening the shaft that it's going into, which can lead to splitting in your resin. It can also lead to the possibility of the male key shearing off and causing problems for your model. It's a real problem I see with a lot of people that think they know how to key a model, but ultimately it can lead to some real trouble issues. What else we got for questions since you're paying attention?
At the what is your technique for removing supports?
I use, we use at the shop, we use micro sanders. And a micro sander, you can find a micro sander at Micromark, and I really strongly recommend them. They're almost like a modern toothbrush where they oscillate side to side and they don't use rotary action. If you don't use a sander like that, a micro sander, you can actually just sand them off with a little bit of sandpaper. You also want to get some, you want to get a nice pair of shears. You can spend some real money on something like a Xuron, which I actually have Xurons here. Actually, I'll show you guys. So Xurons are really, really nice, but they're really meant for really nice plastic like Gundams. You can get these. These are a dime a dozen. You just buy them and you go in and you take the supports off. But when you're cleaning these guys, I like to leave a little bit of meat on there and just take it off with the sand, with the micro sander. I don't have it here, but if I have a nice tall nub, I can come in with this guy. I can put that right on the surface and just take it off clean. These cheap ones, you're going to go through them. You're going to throw them away. You want something nice though? Don't use these on resin. Also, Sanding resin, you might want to get a decent respirator. Health and safety is important to me and the team that I work with. The resin will irritate the lining of your throat, and we're not sure how the resin will affect you over the period of your life. So wear either a dust mask or a respirator, or work in a clean room where you've got a vacuum pulling the dust away from you. You do not want this stuff in your body. Also, wearing Nertile gloves wouldn't go amiss, or putting on a lotion that you can wash off at the end of your workday.
So why wouldn't you just use a Dremel?
Oh, yeah, you know, Dremels are great if you're working on wood, but they don't do good on resin. It's got rotary action, and the Dremel can skip across the surface, creating notching in your model. They can also chip the surface because they're so aggressive. I really don't like Dremels for resin cleanup at all. I think they throw a lot of dust in the air. But more importantly, like I said, they can cause skipping across the surface of your model. Where the micromark sander I was talking about, it just does this, and it's a little tiny pad, not too much bigger than your fingertip, and they come in multiple shapes, and it just goes and it's so easy. It makes cleaning up and post-processing your models infinitely easier. And it's actually a joy to work with. I could actually get in here and work between these fingers with the triangular one, with a triangular head, and just kind of clean those up really nicely. Also, don't use metal tools on your resin. Metal tools on your resin is just as bad as using a Dremel. It just destroys the surface. They're too aggressive. So, yeah. What else we got?
Let's see. Lucas asked, what grade of respirators do you generally use?
I'm mostly looking at a respirator for removing the dust in that respect, unless I'm doing painting and then I want a different particulate. I don't remember the grade. I always forget. I'm looking for the dust one though, for sanding. I don't remember how the grade goes because I just go and pick up a pack at Home Depot and I'm happy. And it's three. Yeah, it's a pre-filter pack. It's from 3M. It's the one that my buddy Kirk recommends, and it's the easiest to work with. When we're working with more dangerous stuff like fiberglass or whatever, we go and get. I think it's the pink ones, which are really, really crazy. Like they take out everything except for nitrogen and oxygen. But again, I know that stuff, but I know it from the shop. I don't know it offhand. Sorry.
Now, MB753 asked if you could write the name of the clip tools you use. I don't think you could understand what you were.
Yeah, here, write this one down. This one is it's XURON, and that's the Xuron. If you can put that in the chat. The other one, these cheapy cheaps they're no name. They're just a flat cutter. They just cut flat on the surface. These come with most. Anybody that buys an FDM printer is going to get a set of these. But I don't get to use these very much on my FDM because I cut everything in my FDM to print supportless, or I sculpt it to be printed supportless. I hate dealing with supports. Sadly, you can't get away from supports with SLA. SLA needs supports because you can't print flat to the bed. Otherwise, you end up with a whole raft of horrible problems. What else we got?
Let's see.
Yes, Kevin's got me covered on the cheap printer or cutters.
Let's see. Lee asked a little while ago how you fix the stretched polys that we saw on the hood of the Batman.
Most of the time, what I do is I just select them and I delete them. I can actually show you really quickly, and that's kind of a modeling thing, so we'll cover that, sure. It really is just me coming in here and trying to figure out what I can delete, and then I just run close holes. It's just the same thing as we did with the rock. In this example, what I'll do is I'll switch over to selection lasso, And if I just grab the tips like this, and it really didn't do what I wanted. So I'm going to grab the whole thing, make sure I grab it. And then I'll make that a poly group, and then I'll hide those guys and hide these guys. I'll go back as far as I need to go, and probably not much further. So that's going to become a hole right there. And then so now those guys are blue. And then I can come back in here and not do that. So that's going to become a hole. I'll run delete hidden. I'll run close holes. And I might need to do some collapse edging on there, but that's probably good enough. It might not even need the collapse edging, because again, this model is probably going to be about 14 inches off the base. So that's going to print just fine. But that's how I do that. I mean, it's really basic stuff. That stuff's basic stuff. Those things, again, the main reason we clean those up is you don't want floaters in your resin. And I'm looking at this as a resin print because most of the time characters are resin or SLA printing. So yeah. What else we got? Come on, guys. This is your time. We're here for you. Mike, you still there?
Did that disappear?
You did for a minute, yeah.
Oh, there I am. Let's see. So best way to get rid of floaters, auto groups?
Yeah, you want to run auto groups and then delete hidden. They happen in most models when you start running the Boolean operations to get rid of them, and they go from there.
And your mold jacket printing method for the vinyl,
yeah.
How hard was it to come up with the method?
We had to spend a couple of weeks on it. Kirk happens to be a master mold maker, and he just told me what the parameters were, and then I had to sit down and go through the process. So for those of you that don't know, a mold jacket is the heavy jacket that holds the silicone so that you can rotocast the model. And rotocasting allows us to print large objects with a, say, a 10 millimeter or 8 millimeter thick shell, and then backfill it with polyfoam to keep it light and give it strength. But it also does a lot of other purposes, or also has a lot of other purposes. With a mold jacket, you can reduce the amount of silicone you use. You can also add longevity to your silicone mold, because the mold comes apart like a sock coming off of a foot. Whereas a thick, heavy mold doesn't have as many pulls on it. A mold that is done with a mold jacket, if you take good care of it, you might be able to get close to 50 pulls on it before the mold starts really breaking down. Whereas a block mold, generally speaking, because of the rigidity of the mold, those are lucky to get 35 pulls before they start breaking down. So the process took us some time. We had to really go through and go back through the process. And the reason that we wanted to go to 3D printing our mold jackets was, one was to save money, but it was also to move away from fiberglass. Fiberglass is expensive, it's heavy, it uses an acid to catalyze the fiberglass. It's nasty stuff, and it'll cut you up pretty badly too if you're not paying attention. But being able to 3D print them means that we can actually 3D print them along with 3D printing the model, which means that we can save some time, money, and be a little bit safer. So there's a lot of benefits to 3D printing a mold jacket. And the other thing too is that we can get very discrete measurements about how thick we want the mold jacket to be. Right now we're looking at running our mold jackets at about 10 millimeters, and that means that we're saving a lot of money on resin. and we can do some other neat tricks with it too that I actually talk about.
Oh,
Yeah.
let's see. Saw a good one. MB753. You'll like this one. Said, how do you print lassos and ropes?
I need to talk to Spicer about that. I'm really concerned about the lasso rope in this model. Generally speaking, we recommend not to do lassos, ropes, or chains, or any of that other stuff because it's really, really small and it's going to cause a lot of headaches. It's one of the only issues that we have with this model, and I haven't had a chance to talk to him about it because I didn't notice it until I opened the model today because I had just started working on it. Um, Generally speaking, when we make a model like this in-house, Spicer's more of a client, but when we make a model like this in-house, we usually provide either wire or tubing or something that we can flex and bend. I might actually have some wire here. I don't, but what could make good wire is basically wire that you have like for your cables. This stuff can be shaped and formed and then put into the grip of a character's hand and do the same thing. Plus it's consistent, whereas with a 3D printed version of it, it's going to be a crapshoot as to how well it's going to come out. Not to mention that this wire here is probably this wire is pushing the minimum of about 4 millimeters. I really wouldn't want to print the cable for Batman. Any thinner than this, but I can go and buy cable that's any size I want because there are machines out there for just that sort of thing. So sadly, sadly, I'm going to have to talk to Spicer about removing the cable from his model. Yeah, cable's one thing that we can use. I was actually going for, I have a drawer of parts here that I'll sometimes source, and it's in a different box, of course. I have a different box that's got a bunch of modeling tubing. So yeah.
Lars asked if the key insert used in the Boolean demo came already divided into groups.
It already comes divided into groups because it's a brush. It's just a brush that I draw out on things. I'm going to show you guys how to make that. It's really pretty standard stuff, but it's one of those things where even the one that I use on the day-to-day, I still make minor modifications to it because I'm trying to, like, I don't know, tweak it. And it's a tool that's used regularly. It's one of 5 tools that I use for cutting up or building models keys. And that was a straight cut, just so you know. There's actually 4 types of cuts. There's a straight, there's a contour, there's a coffin cut, or coffin key is what it is, which I use usually on things like dinosaur heads. When I'm asked to do dinosaur heads, they usually get a coffin key. It's basically just an elongated key, and you're picking how you want to cut it. And then the other one, there is a 4th one that I came up with a name for, but I can't remember it off the top of my head because there's a lot of information rattling around in there. And I'd have to look at some of my notes, but it is talked about in the course. But the contour cut and the straight cut are dynamically very, very different, and they serve completely different purposes. And sometimes when you're making keys on models, there's no right way or there's no best solution, and you're better off doing a straight cut than a contour cut. However, with Batman, if I can do it, I'll do a contour cut with Batman's head and cowl so that the head comes off right around that cowl seam. That would be the most ideal way to remove the head so the head prints separately from the body. But a lot of times I end up using straight cuts on things like arms and legs because there's no good way to do it. In this case, though, I might be able to do one here for the going into the hips. This arm might be able to do right off of the. That's going to be a contour cut right off the glove. And same with this one. So in this model, it's a very different animal than models that Spicer and I have done in the past. So I might be able to do contour cuts for everything on this model. We're just going to have to see how it goes and what's necessary to get the job out the door.
The other key is the cuff key.
Oh, the cuff key. Well, the cuff key is this. So a cuff key is basically a straight or contour key, but it comes with a cuff on it. And this model's made by my very good friend Anthony Watkins. I don't get to talk to him very much. He's kind of shy. And what it is that he hid the seam with a cuff, and it's a way of hiding where your cuts are and such, so that the model looks a little bit sharper, and the person painting it or person that purchases it doesn't have to go in there with epoxy sculpt or green stuff and then repair the model. That's actually really, really useful in a lot of places, and it comes up often, but it all depends on what your need is, and that's what keys are all about. You're trying to optimize your parts so that you can fit them either in the printer or in the mold space that you have. Are you going to do a pressure cast? You're going to do a rotocast? You're going to work off of an SLA or an FDM? What's the purpose of breaking the model down? Batman's kind of unique, though. I'm looking at Batman more and more as we talk, and I'm thinking about that continuous printing. And I would love to try and print him, if we had continuous printing, I'd love to try and print him in one go. I'd just love to see if we could do it. But I suspect the amount of cleanup, getting in behind the elbows and underneath the arms and behind the legs would be an absolute nightmare. So I think that even if we did have continuous printing and we could print him in an hour, I still would want to cut him up into parts. Just for the fact that I'd be able to clean it up or get at the back of him to paint him. Does the cutting software create holes for C prints, or does that need to be?
That's SLA type of.
Does this cutting software create holes for SLA prints, or does that need to be put in? The different software we use has tools for putting holes in the model. For instance, there's the free slicer that we use for a lot of our SLA prints, which is fairly good. It's called 𝐏𝐏𝐃. It's a third-party package, and 𝐏𝐏𝐃 has the ability to hollow the model and then put a hole in it so that you can have a drain and a vent. Main difference is a drain removes fluid and a vent removes air bubbles, or lets air flow in and out. That's what really the word I should be using. It lets the air flow in and out. The drain lets the fluid flow in and out. Sometimes they're usually at different points on the model. But yeah, the slicer that we use, almost all slicers have the ability to hollow the part and put drains in for SLA, or if you're doing FDM, you can use less or more infill, but you don't really, and you can also do supports, but you can't really do things like cut up or keying in your slicing software. That's why ZBrush is so powerful. I think 2 versions ago, so roughly 2 to 3 years ago, ZBrush couldn't cut up models the way it can now, and I had to use another software altogether, and let's just call it an engineering software, and it was such a bear, and it was so difficult. I'm actually ecstatic that my favorite software package, because I am a fanboy, has the tools in it now that I wish it had, 10 years ago when I started doing this stuff. It's just brilliant that we have them. So yeah.
Were you cutting in a CAD program?
I don't want to mention the software. I don't want to mention the software. It was a bad thing. It was a bad relationship. It was abusive. I have bad memories.
I've used SolidWorks to cut up stuff before.
I honestly, that's what we were using, and
Yeah.
it is a very abusive relationship, and I I don't wish that software on anybody. Um, so yeah,
Yeah, you definitely
software's
can't have an artistic mind and use it
no,
as an engineer.
it's very hard to use. You can't do a good contour. Well, let me phrase that. It's exceedingly difficult to do a good contour cut in SolidWorks. It is just very, very difficult to work with. Plus, I can work with multi-million polygon models here, and SolidWorks, or that other software, I shouldn't really be saying this, that other software has a lot of limitations. I had to reduce the models quite a bit just to make them workable. Yes, Fusion 360 can do it. A lot of software can do it now. Actually, almost all major packages can do it now. It just wasn't available 10 years ago. I think Fusion 360 came out, what, 4 or 5 years ago? And it just, you know, when you're in a pipeline, you sometimes stick with the tool that you're familiar with. So. What else we got, guys? We got, well, actually, we ran out of time. There's two other topics I'd like to bring up, if that's all right. Do you still have
Yeah.
the?
As long as you guys want to stay for a little bit, then yeah, we can.
So really quickly, guys, one of the reasons I'm so excited about this is as someone that's always looking for the future and trying to make better stuff. I started out learning from Tim Bruckner. And if you don't know who Tim Bruckner is, you need to look him up. I wanted to make toys, among other things. I wanted to work in video games. I wanted to make toys, and I wanted to do all the fun stuff that I'm somewhat doing now. You know, I get to make toys at least. My point is that there's a couple of things you guys might not know about, you might want to be aware of, is that we're going to be entering, and all of the futurists are talking about it, with 3D printing, we're going to be entering another industrial revolution. 3D printing is becoming ubiquitous. It is becoming everywhere. I think with the continuous printing printers that are going to be coming out in the near future, we're going to see a huge growth in the availability of what people can make at home. If you haven't looked them up, EOS can print in titanium. They made armor for Adam Savage. Absolutely amazing stuff that they actually shot at with bullets. So printing is going to become more and more available and more part of our daily lives. So participating in this stuff is so crucial. It's one of the reasons that I'm super excited to be teaching this course, to just sort of help you guys really get a grasp on this. The other thing that's really crazy about 3D printing, which a lot of people don't think about, is that this is distributed manufacturing, which means no more need for big old ugly warehouses. You print on demand for the things that you need. You can get replacements for the things that you've purchased before that have either worn out, broken, or failed, like hinges or whatever. So the two big topics that we don't really get to talk about in the course, but that are underlying of this thing, is distributed manufacturing and this new industrial revolution that's coming up, which I think is the third, maybe the third or fourth, I can't remember. And it's really exciting to me. It's terribly exciting. And I really hope that it's something that you guys are thinking about, something that you guys are talking about. Somebody's heard of Tim. I hope you guys have heard of Tim. Most of you guys have probably seen his work and didn't know it. He's an exceptional guy. I wanted to get an interview with him, but he's an old school guy, and he's just very generous with his time. And it was a pleasure to talk to him when I got to talk to him. But yeah, do you guys have any final questions before we close out tonight? Let's go with that. And I also want to state, I'm really excited for those of you that want to take the course. And I'm looking forward to meeting a bunch of you and seeing what you guys bring to the table and trying to help you guys figure out how to improve the quality of your work. So
one thing we can do is we can share your course information. Can you all see my screen?
I can see your screen. I don't know. Can you guys see your screen? Just so you guys know, just a little quick note. I know Mike's going to say something here. The model is from my World's Overrun terrain stuff. It's a demon, but the guy up front is the whole model, and then the red guy is the SLA style cut up job. And then I took that a little bit further and I took it and cut it again so that it could be printed in FDM without supports. This is actually a method for working. If you have an FDM printer, or if that's all you have access to, you cut it up in the SLA style, and then one more set of cuts, and you can reduce the need for supports and cut it up or print it out on FDM. So it's a really, really neat way of doing things. It's not always recommended, but it does mean that you can get the desired results if you're clever.
Now we have actually extended the registration until February 7th for this course. It is filling up quick, so you need to go ahead and register if you haven't. You want to tell them a little bit about what we're going to be doing in your course?
Yeah, the course is going to cover both SLA and FDM style printing. Mostly we're going to be looking at models that you guys have available, or we'll be taking a ZBrush already available model, and we'll basically be going over everything you can do to improve the quality of your printing, from hiding Z layer lines to how to make a proper contour cut, how to take advantage of a model that is made in parts versus a model that is whole. You'll be able to do all sorts of wonderful things with the slicers and experimentation there. In fact, we'll talk about how you can use an SLA slicer to improve the quality of your FDM printing. There's a lot of really neat little tricks in there. And also, there is a forum that's associated with the course, so you guys can ask questions there. Mike and I will probably have to look at that stuff together a little bit, but we'll try and make sure that you guys are constantly getting input. I'm really, really excited about being able to share this information because I want to see more people making cool prints.
Let's see, your course is, you got, what, 8 weeks?
I think it's 8 weeks.
Yeah, 8 weeks of awesome content. It's the third time you've run it?
Yes.
Yes. And it's an amazing course, guys. You definitely want to sign up and get into this one. We'll have live sessions that you can attend if you purchase the live course. If you only do on demand, it doesn't include any of the live. Both of them, you get all your content up front. You work at your own pace. Each live session, you have the opportunity to submit homework, get critiques. You can even get critiques on anything else that you're working on. It doesn't necessarily have to be something you're working on for the course. So if you need any feedback or critiques on your own work, Eric would definitely handle that for you.
Just so you guys know, before I started working with Mike, I taught at university for 6.5 years. So I'm more than happy to look at models with you guys and talk to you guys about them, as long as we're not cutting into other people trying to learn how to do the engineering and the model prep and the getting prepared for the 3D printing. I'm more than happy to talk to you guys, and the more you guys are engaging me, the more I will engage you, which means that a scheduled 1 hour can easily turn into a scheduled 2.5, maybe even 3 hour. At some point, though, I am going to get tired and want to go get a cup of tea, but I'm more than happy to talk to you guys about the work that you're doing.
Yeah, and the live course is $497. You can also split it up into 3 payments, 3 different months, $175 a month. That'll help you out there. Software requirements, they're all listed on here.
Can you go back there just real quick? Just so you guys know, that sculpture right there, that was done at Collapse Industries in Pensacola. That is right out of our printer. Right out of our printer. I think he knocked the supports off the back of the model, wiped it down with a cloth. maybe through a little bit of alcohol on it, rubbing alcohol, but that model is not gone through any significant post-processing. If you know how to engineer a model and orient them and get the best possible results out of it, your prints can look as good as the sculpture you made.
And I mean, has anybody else got any more questions? We also, I know we promised you guys some brushes. We are still working on the set. It will probably be available next week, and everybody get a link. You'll also get a link to this webinar to rewatch it if you want, or share it with your friends. And we also have another thing to give you. Since you attended the webinar, you can get $100 off the live session if you use this coupon code in your checkout, or RMP100. That'll give you $100 off of the live. It only works on the live, so yeah, guys, definitely jump on because space is limited and it will fill up quick. So let's see, one last question. Is it better to remove the support before or after curing UV?
Yes.
You said before or after.
I don't have a distinct answer for that. I think most of the time we knock off the bulk of the supports before we go to UV curing. But that doesn't mean that the surface nubs have been removed. It's just the bulk of it. The bulk of it comes off. That one I'm going to have to check with Kirk and James about, because they're the ones that usually clean up the models. I usually just make them, I'm mostly on the software side of things. I will talk to them and I will see what they have to say. But I'm pretty sure we knock the bulk off and then they go into the UV cure. So yeah, so Kevin's a good friend of mine. He prefers to knock them off before, and that makes the most sense. The resin is soft; it's easier to work with. Yeah, UV curing. If you snap it more, it's brittle. The resin pockmarks more. Yeah, so that goes along with what I understand as well. Oh, hey, Lars showed up. Hey, Lars, man, thanks for coming in. Yeah, I don't have a resin printer here. That's at the shop. So. Those are run by my two different partners. So yeah, Lucas, no problem. It was good to have you guys.
All right, is there any last questions before we wrap it up? Anybody? Last chance.
All right, guys.
All right,
Thank you
thank
so
you
much.
very much for coming, and I will send everybody a link to the actual course so you can sign up in your email, and I'll also give you the coupon code in there as well. So yeah, we look forward to seeing you sign up and get in this awesome course with Eric. He's an amazing instructor. And thank you guys very much for coming.
Have a good night.